Hello friends, welcome to this class, physics class. We want to treat briefly scalars and vectors. Scalars are quantities that have only magnitudes, that is, they have size. You are concerned with their size. The direction is not important, like temperature, time, current, distance, and on and on. While vectors are quantities that have both magnitudes, we are concerned with their size. We are also concerned with the direction in which they are going. Now that is for elementary physics. Now high level physics defines scalars as tensors of order 0, while vectors are tensors of order 1. You have higher order tensors, but I wouldn't boggle you. I wouldn't disturb you with that. It's not important. Now, if you have, for instance, a body, a mass, and a force is acting on it, pulling it in this direction, pulling it in the direction F1, and another force is pulling it towards the direction F2, such that an extrapolation of this line makes them intersect at an angle of 90 as an intercept, angle of 90. Now, from this point now, let me resketch it here. F1 and F2. Now, from this point to this point is magnitude or size of F1, of F2. From this point to this point is the size of F1. If you observe, you notice that F1 is longer than F2 is longer than F1, meaning that F2 is greater than F1. So the magnitude tells you by the size. Why this arrow? This arrow tells you the four cardinal points: east, west, north, and south. So it is moving towards east, while this moves towards north. So we've recognized the fact that this is force. The forces are vector quantities. They are scalars of order 1. And so the dimension is from this point to this point, the size, or magnitude, if you like, while the direction is in this direction. Now, if F1 were to be greater than F2, it will be longer, while F2 will be shorter. So this is F1, this is F2. Acting in the same direction, but now different sizes. Good. Now let's solve the problem. If you are solving problems relating to forces, you must recognize how to resolve forces into components. And again, you look at what we call a parallelogram of forces. If you have, for instance, this is 3 Newton, this is 4 Newton, okay, acting perpendicularly, and we have to determine the resultant force. Usually, at the point of intercept, we draw the arc. So of course, you just complete the the rectangle. You complete the rectangle. If you calculate R, you complete the rectangle. So this opposite sides of a rectangle are equal. This one is also equal to this one, okay? Now what it means is that here is also 4 Newton. So R becomes, use Pythagoras theorem, because here is a right angle triangle. Square of hypotenuse equals sum of the squares of opposite and adjacent, equals 3 squared plus 4 squared equals 9 plus 16 equals 25. So R, you take the square root of both sides, equals 25. That gives us 5 Newton. I know the square root of 25 is plus or minus, but we are concerned with the positive forces, okay? Now, this is on what you should know about that. Now, what if these two forces are inclined not at an angle of 90, 4, 3 Nathan, and this is say 120 degrees. Now we resolve and we are asked to calculate the resultant force R. Again, the R has to come from this point of intersection. R from this point of intersection. So what we now do, that takes us to what we call parallelogram of forces. You try and establish a parallelogram. Of course, a parallelogram basically has, this is R. In a parallelogram, opposite sides are equal. Opposite sides are equal. 1, 2, opposite sides are parallel. 3, opposite angles are equal. Those are the 3 basic properties of a parallelogram. Now, what it means is this sides and this sides are parallel. While this side and this sides and these sides are parallel. Okay? Now, what it means here is we are required to calculate R. This angle is also 120 degrees. Of course, the sum of the interior angles of this is 2 and minus 4 right angles. So I know it's 4 times 2 is 8 minus 4 times 90 is 360 degrees. So here is x, here will be also x. So that we have x plus x, 2x plus, here is 120, here is 120, 240 degrees equals 360. So we're having x equals 360 minus 240 is 120 over 2. That gives us 60 degrees. So here is 60 degrees. Here is 60 degrees. Now, we can calculate what R is. See, we know here is 490. Here is also 490 because opposite sides of the parallelogram are equal. So we're now having a shape like this. 490. Another shape like this. This is longer. 390. And we have 60 degrees. This is R. Okay? So it gives us a scaling triangle. Scaling because none of the 3 sides are unequal. So it's a scaling triangle. Now, what we have to use what we call a cosine rule in mathematics. So if you have, here's A, B, C. R becomes small b, here becomes small a, here becomes small c. So what we're looking for is R, which is R squared, which is equal to B squared, equals, you know what I mean in mathematics, equals A squared plus C squared minus 2 AC cos B. Okay? So what it gives us is A squared, which is 4 squared plus C squared, 3 squared minus 2 times 3 times 4 times cosine 60. That gives us 16 plus 9 minus 2 times 3, 6 times 4. 6 times 4 is 24. The cosine of 60 is 0.5. Because the sine of any acute angle equals the cosine of the complement. So cos 60 is something like sine 30, which is half. So 2 times, this is 6 times 4, and that, so this is 25 minus 0.5 times 24 is 12. That gives us 13. Therefore, R equals 13. We take the square root of both sides. Square root of 13. Square root of 13 will give us 3 point something. This is root 3 nothing. So root 3 nothing, square root of 13 is an irrational number. So you leave it as solved, or you use the calculator to compute it so that you can find it. I hope this helps. Thank you very much.